So 5.2 is building on what we did yesterday, where you multiplied monomials together. Today we're going to talk about multiplying polynomials, so that'll be a binomial times a binomial, or a binomial times a trinomial, and we'll learn a couple different methods on how to best do that. Okay, so we're on page 177 if you're in your hard copy. So our essential question, how do you multiply binomials and polynomials together? Hey, and quick reminder, what's binomial mean? How many terms? Two. And what's polynomial?
More than two.
It just means many, really. So it could be 1, 2, 3, 4, any amount. Today we're mostly going to do binomial, 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 and trinomial. Okay. All right, so modeling binomial multiplication. I'm going to jump us into tiles to show you one time a visual representation of how we do this, because that will then tie into what some of you guys know as the area or box method. Okay, and then I'll show you the other method, which is distribution. So as we come back here, we look at that product, and we had a 1x squared, we had a negative 1x, and then a negative 2 for our constant. Okay, and so area model, which comes off of those tiles, is I would have the x plus 1 down the side, and then an x minus 2 across the top. We draw our box. That's why some students call it a box method, or an area model, because I'm multiplying a length times a width, essentially. And then this is just like your multiplication tables you saw in elementary were probably posted on a wall. You had 0 through 10 or 0 through 12, depending on how big it was, across the top, and then same thing down the side. And where the two matched up, you multiply those together. So if I had 2 and 3, where those boxes met, I'd have 6 in there because I'd have 2 times 3. You're doing the same thing here. So what that means is this x, as I multiply it with this x, they meet in this box here, meaning I get x times x, which is x squared. And then x times the negative 2 is a negative 2x. And then we go across the bottom, so I go 1 times x is x, and 1 times the negative 2 is a negative 2. Now, we add all of this up. You can write it all out, but a lot of students, why they like the area model, is our first term we have x squared, but then we look at our diagonal, and those are generally where your like terms are going to be. So I have x and negative 2x, which is negative x, and then I have the negative 2 there to finish it, which is what we came up with there. And then the last method is distribution. So if I take this x and I'm going to distribute it to that x, so x times x is x squared, and then I take this x and I'm going to distribute it to that 2, and so I get negative 2x. Notice I take each term from my first polynomial and I distribute it into my second polynomial, then I move on to the next one. So then I get 1 times x, which is x, and then 1 times the negative 2, which is negative 2. Now I combine our like terms, so we have x squared, negative 2x plus x is a negative x, and then I have the negative 2. So as you can see, 3 different methods that all work the same. I personally don't care which of the 3 you do. Most of you probably won't do tiles. You're not going to draw tiles every single time. But you can do a version of the tile. That's what the area model is. Okay? Or you can distribute. Both of them work perfectly fine. Some just have a preference for one over the other. So let's look at a couple more examples here. So first one, I'm going to multiply by distribution. The second one I'll do area model. So I look at the first term here. We're on page 178. I'm going to take this x and distribute to my x there, and I get x squared. And then x times 2 is 2x. Then I take my 5 and distribute, so I get 5x. And then 5 times the 2 is 10. Combine your like terms. We only have an x squared. I do have the two x's, so that gives me 7x. And then the plus 10 at the end there. Now for the second one, I'll do the box or area model. So I get 2 plus 4, and then x plus 3 across the top. Draw the box. And then 2x times x is 2x squared. 2x times 3 is 6x. 4 times x is 4x, and then 4 times 3 is 12. Go ahead and add. Top left, I have 2x squared. My diagonals are where you're going to have your like terms. Now, it's not always true, which you'll see on the next slide, but if you are going to have like terms, they're going to be on your diagonal there. So 4 plus 6 is 10x, and then my constant of 12. Plus. All right, let's do a couple more here. So the first one I will do as a box method, because you'll see where there's not like terms on diagonal on this one. So then I get x squared plus 3, and then x plus 2. So x squared times x is an x cubed in our top left. Then x squared times 2 is a 2x squared. 3 times x for our bottom left is 3x. And then 3 times 2 is 6. So top left we have x cubed. And then this time you notice we have 3x in 1 and 2x squared. Those are not like terms because they do not have the same exponent. So we would just have 2x squared plus 3x plus 6. Okay, so this one ends up being 4 terms because there are no like terms that we can combine there. Alright, second example I'll do with distribution. So I can distribute 3x squared times x, just because there's an extra x squared in there. Doesn't change anything, so that gives us 3x to the cube. Then we have 3x squared times 5, which is 15x squared. Distribute our negative 2x in, and we get negative 2x squared, and then minus 10x. So this time we have like terms, so I have 3x cubed plus 13x squared minus 10x. Now, as you've been looking at yours, they talk about or use this term FOIL. And what FOIL stands for is first, outside, inside, last. And it's a way to organize to multiply together. My issue with FOIL is it only works with a binomial times a binomial. And we're going to be doing more than that. And so if you learn how to do distribution or the area model, then you can multiply any polynomial times any polynomial. If you try to learn just FOIL, that only works for a binomial times a binomial, which is then very limited of what you can do with it. And too often students will use it in other multiplication of polynomials when it is not usable, which I'll show you in the next slide when we do a binomial times a trinomial. Okay, so looking at this one here, if I'm doing this problem. And I did FOIL, which FOIL is first times first, outside term times outside term, and then my inside term times my inside term, and then my last times last. What is the issue with that distribution pattern? Yeah, we did not touch our negative 5x. So you can see why it works with a binomial, because there isn't that middle term from a trinomial. But now it does create a very big issue when we try to do it to anything else. So that's why I do not like the FOIL method. And that's why I like distribution or the area model. Because then if I go to distribute this one, x times x squared gives me x cubed. X times negative 5x is a negative 5x squared. X times 4 is 4x. Then I distribute the 2, and notice I took the x, my very first term in the first polynomial, and distributed it to all the terms in the second polynomial before I move on to the next one. Then I get 2 times x squared, 2 times negative 5, which gives me a negative 10x, and then 2 times 4, which is 8. Combine your like terms. There's only one x cubed. I have an x squared and x squared. That gives me a negative 3x squared. 4x and negative 10x is a negative 6x. And then my constant is plus 8. So not a whole lot more work. Just got to pay attention, make sure we distribute to every single term. Okay, this next one I will do with area model, so you can see that that also works with a binomial and trinomial. You see the small changes, we'll just have one more column. So I have at our quiz here. So this first one we have x plus 1 times x minus 2, which was actually we did worse on than the second one. My guess is because we actually had to combine like terms on this one, we made a mistake there. So when I go x times x, I get x squared. X times negative 2 is a negative 2x. Then I get 1 times x is x. And then 1 times a negative 2 is a negative 2. Combine our like terms in the middle, and we get x squared minus x minus 2. Giving us the answer of A. Whereas when we look at number 2, I have x squared times x, which is x cubed. X squared times 6 is 6x squared. 3 times x is 3x. And then 3 times 6 is 18, giving us C, because there are no like terms. So we did better on that one than we did on number 1, even though they're basically the same steps. We probably messed up on our combining like terms. So make sure we pay attention to that little bit there. All right, number 3, again, is another just distribution. So as we take and distribute the 3x, I get 3x, to the fourth. And then 3x times 4x squared is 12x cubed. And then 3x times a negative 7 is negative 21x. And then I do the same thing with the 1. So I get x cubed plus 4x squared minus 7. Combine your like terms. We only have an x to the fourth. So I get 3x to the fourth. X cubed and x cubed combines to give us 13x cubed. Now we have an x as our next one, but we want to write it in standard form, which means you go decreasing order of exponents. So actually the next exponent would be our x squared. And then our x. And then our constant. And then that gives us A as our answer on that one. And then last is our word problem. So in this one we're told landscape architect is designing a rectangular garden in a local park. The garden will be 20 feet by 15 feet. So you have something that looks like this. And then he wants to draw or put in a walkway that goes around it. Now a lot of students on this one struggle with the term uniform. What does uniform mean? Huh? Yeah, everything's the same, right? If you're on a team, you wear a uniform. Means you look in a uniform manner. It looks the same. So all these sides, all the way around, whether it's on top, bottom, left, or right, is always going to be the same distance. So if I know that this distance here is going to be 20, and then what do I do with that sidewalk? What is that doing to that 20? Does it make that side longer or shorter? Well, if I have 20 here, I'm going to put a walkway on each side. Did that increase the size of that distance or decrease it? It's increasing, so mathematically, what does increase mean? What are we going to do?
To go up.
To go up, so we're going to add. And do we know how big that walkway is?
20.
We know the walkway is 20?
We know the garden is
The garden is 20, so what is the walkway? 22? So if we don't know, what do we call it? Yeah, in math, if we don't know a measurement, a distance, a number, we call it a variable. In this case, we can use x. And then our other side is going to be 15 plus x as well. So if we want to know our area of this, we're going to distribute. So I get 20 times 15, which is 300. 20 times x is 20x. X times 15 is 15x. And x times x is x squared. Now we want to combine like terms and write in standard form. So I'll start with x squared. Then we have an x and an x, so we get plus 35x. And then our constant is 300. So then that would be b. Alright, so that brings us back to our essential question here. So how do you multiply polynomials? We can one distribute. Okay, and what was the other method? Well, we can do tiles, which most of us probably aren't going to draw tiles every time. I mean, you can if you want to. But what is the one that relates to tiles without drawing the tiles?
Where did that go? Like a Punnett square?
We had the square or the box or area model. Okay, so yeah. So you can do area model or distribution to multiply polynomials. Okay, which brings us to your assignment. Okay, so pay attention to that. Your last ones are going to be some word problems and higher order type questions. Okay, so you'll start to see those on quiz and tests. So we'll practice those a little bit more. This assignment is due on Thursday.